This week we have learned about other devices. I would like to continue upon my brief previous about TFT lifetime. And at the right side of the picture, left side of the picture is MOSFET, and right side of the picture is the tunnel FET. But what is different between them is the source and drain. Type of the source and drain. For MOSFET, they heavily adopt N-type for source and drain, but for tunneling FET, we heavily adopt source by heavily P-type, and on the drain side we heavily adopt N-type. And through this diagram, there is no injection in tunnel FET, but MOSFET has an electron injection from source, and there is no impact on electric field concentration at source and gate edge. The long-term lifetime of MOSFET is primarily determined by electron injection from the source. In tunnel FET, on the other hand, the source and drain are different polarity, and electric fields become particularly concentrated at the positive sources and the gate edges. Electron injection comes only from negative drains because the negative type drains were under voltage. In this accelerated testing, there was little voltage difference between gates and drains, which substantially inhibited the supply of electrons from negative type drains. This is the reason for the longer lifetime of tunnel FETs. For next page, I'm gonna talk about body thickness effect. The thinner body has lower subthreshold swing due to the effective gate control. When the body is too thin, driving current decreases. And for the better gate control, we have to we have to control the thickness of channel to be very thin, so the body thickness. How will we gonna make the body thickness thinner? Will show us the different graph by the gate control. And for next page, I'm gonna introduce about channel length effect. Tfet subthreshold slope improves significantly at longer gate lengths for a 10 nanometer body with a single gate, and lateral field is bigger than vertical field, then it will be very poor swing, as you can see in the left side of the diagram. And if the gate length is getting smaller, bigger, the subthreshold swing will gonna be very steep, and it will be very good operate as a good device. And for last, I'm gonna talk about multi-gate structure. And at the left side of the graph is thermionic emission, and right side of the graph is the interband tunneling. And as you can see, for the MOSFET, it usually use diffusion current. It passes over the band gap source to drain. And for the TFET, it usually uses the concept of the tunneling. If the bandwidth is getting smaller, and also the barrier will gonna be not the barrier, the barrier gonna be thinner, so the electrons will gonna tunnel through the p side conduction band to the channel side conduction band. Valence band for the p-type. Increased gate control continues to improve TFET characteristics, whereas MOSFET is limited by 60 mV per decade. And for the better gate control, we usually use multi-gate structure, and nowadays we are mostly use multi-gate structure in our engineering. Thank you.